Hi, I'm Nicole T. Laserna from NS183, and here I will demonstrate to you how to solve the UKC and the squat of the ship. So the given problem is the ETA upon passing a critical place at Avon Mount with the charted sounding of 5.0 meter was 11:45 hours on January 1, 2015. If her calculated rough upon passing was 7.0 meters, solve for her UKC when passing the place. So first we're gonna write the time and of course the height. So you can see. So the time is 0338 and 10:31 and 16:08 and 2309. And the height is 10.7 meters, 3.8 meters, and of course 10.8 meters and 3.6 meters. So first we're gonna get the 10:31 hours and the 11:45 hours and 16:08. And we're gonna subtract the 10:31 hours and the 11:45 hours, and if we solve it, the answer will gonna be 1.223 hours. 1.23 hours, and the next step is that we're gonna subtract 10:31 and 16:08. The answer will gonna be 5.62. There. And we're gonna write here that 3.8 meter. So we are finding the x, and we're gonna put an x here and 10.8 meter and the given 7 there. So first we're gonna write the 1.23 and the 5.62 and the x and 7. So we're gonna perform the cross multiplication here. There. We're gonna times it, so 5.62 times 8 is gonna be, the answer will gonna be 5.62x, and 7 times 1.23 times 7, the answer will gonna be 8.61. So it's gonna be the x is equals to 8.61, and we're gonna divide it by 5.62. So the answer will gonna be 1.53. So that's the answer. So we're gonna get the 3.m. We're gonna put it here, 3.8m there. So we're gonna add these two. So if we add this, the answer we're gonna be 5.33 there, 5.33m. So this is the answer to the 11 and 45 hours. So this is the 11 and 45 hours. So the answer there is the 5.33 m. And we're gonna write the CS. So the CS is already given in the problem. The CS is 5.0. There. Now we're gonna find the TDW. So how to find the TDW? We're gonna plus these two. We're gonna plus the 11:45 hours and the CS to get the TDW. So if we plus them, the answer will gonna be 10.33 m. There. So the graph. So here comes the graph. The graph is also given in the problem. The graph is 7.0 m. So at lastly, to get the UKC, we're gonna minus the TDW in the drop. So if we minus those two, we can now get our final answer, the UKC. So we're gonna minus it, 10, 33, 10 minutes. The answer will gonna be 3.33 m. So that is the UKC. So now I will demonstrate how to solve the ship squat. So first we're gonna read the problem. So the problem is solve for the squat produced by a ship with block coefficient of 0.85 making good 10 knots. Solve for the squat at deep and shallow water. So we're gonna find the deep water and the shallow water. So first we're gonna write the deep water. There. So that's the first thing we will gonna solve. So squat. So the formula of deep water is block coefficient times the speed and squared, and we're gonna divide it to 100. So what is the the block coefficient is 0.85 times, so the speed is, it said the problem said that it is 10 knots, so the speed is probably gonna be 10 squared. Then we're gonna divide it to 100. So the answer will gonna be 0.85 m. So the next one is the shallow water. So of course the formula of how to solve. So you need the squat in open or in deep water times 2. So the squat in open or in deep water, so it's like the block coefficient, so the number there is gonna be 0.85 m, and we're gonna times it into 2. So the final answer will gonna be 1.70 meters. There you go. And that's how you do it. So to get the draft of the ship, first we're gonna write here draft. Dear draft. And 7 minutes plus the ship squat of the deep water, so 0.85 m. There, so you're just gonna add it and the drop of the ship will gonna be 7.85 minutes. So that's the drop in the deep water. There you go. So again, the next one is the drop of the shallow water. So it's just the same, 7m plus the ship's squat of the shallow water, 1.70 m, and if you plus it, it's gonna be 8.70 m. So that's the drop of the shallow water. So the next one we're gonna get is the required time in passing the critical place. So first one is we're gonna write the 10 and 31 hour, and of course the x, and 16:08 minutes, and here's 3.8 minutes, 6.0 m, 10.8 m. So we're just gonna minus it. So here's one to first. So 1031 x equals to x, and here 5.62 hours. There you go. And of course here gonna minus it. So 3.8 m minus 6.0 m is equals to 2.2 m, and of course the last part, 3.8 m minus 10.8 m, so 7 m. So we're just gonna write the one that we minus here, x, and 5.62, and of course the 2.2 and the 7. So we're gonna perform a cross multiplication there. So 5.62 times 2.2 is equals to 12.36. 7 times x, 7x. So 12.36 divided by 7. So we're just gonna divide it. The answer will gonna be 1.77 hours. So first we're gonna get the 77, and yes, so it's gonna be 0.77, and we need it to times to 60 to know what is the minutes. So 0.77 times 60 is equals to 46 minutes. There, 46 minutes. So it's gonna be 1 hour and 46 minutes. There. So we need to get this, the 10 hours and 31 minutes. 10 hours and 31 minutes. So we're just gonna add it, of course. So if we add this, we can now get the required time in passing the critical place. So 46. So the answer will gonna be 12 hours and 17 minutes. So this is the required time in passing the critical place.